Right, so we're up to 1110. We're now up to Parametric's equation of the parabola. Okay, so pretty much everything you will do in relation to questions and exams and your exercises, of course, will all be relating to the parabolas now. Okay, so we just introduced parametric equations and we know what they are, just in simple terms, and now we're going to specifically relate those to the parabola. Alright, so the equation of the parabola can be written as a set of parametric equations. Okay, so if we let x is 2at, so that's what we set. Alright, let's come up with that. Alright, so we simply substitute it into the equation for our parabola, vertex at the origin and it's concave up. What's that equation? For the parabola, concave up and the vertex at the origin. Back to your mathematics.
X equals 4a. X squared equals 4a.
Y
Alright, we got it in the end. I was waiting for the point where I realised, well, one of them's not square. Which one's square?
What page is this on?
This is on page 108. And also we could consider doing after school classes, alright? That's the other thing as well, if you would like to stay hanging out for the afternoon, okay? That is another option. Okay? So if we let x equal 2at, we substitute into that formula there, and we're going to solve for y, okay? So y is going to be x squared on 4a, so I'm going to rearrange it for y straight away. Okay? And then it's going to equal 2at all squared on 4a. So it'll be 4a squared, 2 squared on 4a, going through your algebra rule. Okay, and this will equal 8a squared. Right, so you need to know that. Okay, so you need to know the x for your standard concave up parabola at the vertex of the origin. X equals 2at, so t is our parameter. Introduce that third parameter. Okay, so later on we'll be looking at applications of calculus in the physical world. Okay, you'll be looking at introducing that new parameter in terms of t for time. Okay, so that'll be one application that we'll look at further on. Right, so from that, y is at squared. Okay, so that's your set of parametric equation. So, in the first box, the parabola s squared equals 4ay can be written as x equals 2at and y equals at squared. Now, if we got the parabola upside down, so concave down at the vertex at the origin, okay, all that changes is the y becomes negative, so negative at squared. X's stay positive all the time for this concave up, concave down. Okay, the y will change the sign for there. Okay, now we're going to look at the sideway ones. So if we let y equal 2at, any guesses what x will be? Okay, so x will equal at squared, going through a similar setup. Okay, so we're looking at now our sideway parabolas. Okay, so the equations of those, of course, y squared is 4ax. It opens out on the side. Okay, we simply substitute in there and we would get the same process, same answer. Okay. So the parabola y squared equals 4ax can be written as x equals 2at, x equals at squared and y equals 2at. Now there is an error. Oh no, not there, isn't a question. So similarly, the parabola y squared equals negative 4ax, so we're opening out on the negative side of the origin, okay, can be written as x equals negative at squared, y equals 2at. Okay, so these four concepts you need to know. Question? Right, find the Cartesian equation of the parabola. X is 6t and y is 3t squared. Determine a point on the parabola where t equals 2 and t equals 3, negative 3. Right, we need to now first decide, Cartesian, no we don't actually need to do this. Okay, one question we're about to do, we have to consider the orientation. So x equals 2at, and y equals at squared, because they're both positive. Okay, we match them up. So that's just a side note, sorry, actually this one. That will be our orientation parabola. Okay, so that's just a side note, where they come from. But what we need to do is eliminate the parameter. Okay, so in other words, when it asks you to find the Cartesian equation, you need your equation x equals something in terms of y, or y equals something in terms of x. Okay, so if we solve one of these two equations for t, and then substitute that into the value for t in the other equation. Okay, so which of these two equations am I going to solve for t? Okay, I'm not going to fiddle around with roots. Alright, so t is going to be x over 6. Equation 2, put that in equation 1. So y is going to be 3 lots of x over 6 squared, 3x squared on 36. So y is going to be x squared on 12. So this is really saying x squared equals 12y. Okay, putting it back in the format that we're used to. Okay, but that will be fine. Okay. Right, to determine the point on the parabola where t equals 2 and t equals -3. So t equals 2. Alright, so I've got two sets of parametric equations, x's and y's both relating to t. Okay, so what I need to do is substitute the value for t into our two parametric equations. So x is going to be 6 lots of 2 and y is going to be 3 lots of 2 squared. Going back to parametric forms of your question. Alright, so there is a point on the parabola, f squared equals 12y, 12, 12 on your parabola. Okay, that's what it allows us to do. So that t is -3, x is going to be 6 lots of -3, and y is going to be equal to 3 lots of -3 all squared. Okay, don't forget when we're substituting a negative number in, we need the brackets. Okay, -18, 27 is also another point on that parabola. Right, we're good? Yep. Find the coordinates of the focus and the equation of the directrix of the parabola. You know, there's a typo in the notes. Can you please change? So we've got x equals -1 over 8 t squared. Just cross that negative sign out. So it should be a quarter t. No negative sign out. In example B. Just a quarter t. Okay, because it doesn't match this work that we've introduced parametrics over here. Okay, so we need the coordinates of the focus and the equation of the directrix. Okay, so this is the one we need to have the orientation of the parabola. Okay, so if I write the parametric forms, this is negative here, it will be negative a t squared, because that's where the t squared term is. Okay, and y is going to be 2at, so it matches that form there. So from your parametric equations, you need to be able to recognise the orientation of the parabola. Okay, so any suggestion on which?
From your perspective, it's my perspective.
That?
Yeah.
Okay, right, because x is the one that's got the parameter squared. Okay, so we've got the one opening out to the side. Okay, so from that we need to determine the coordinates of the focus. Okay, and now we can put the focus and the directrix in its correct location. And we need to now work out those two values. How am I going to do that? Okay.
Find A.
Good. Find the focal length. Yes? Find A there. And there'll be A there as well, won't it? Right, so once we get the value for A, we'll be able to very simply write down the coordinate and the equation directrix. Right, so you've got to mix and match, okay? So negative 8t squared is equal to negative at squared. Right, so A is going to be going to be 1 on 8. Remember, A is always positive for the focal length. Alright, and of course it will be the same equation, so a quarter equals 2A. So A is going to be a quarter, and then we move the 2 down the bottom with the 4, so it'll be 1 over 8. Alright, so it doesn't matter which one you do, you'll get the same value. Alright, so to focus, what's the coordinates of the focus? Good. And that's why you need to know the orientation of your parabola, so you've got these things in the correct location. And directrix. What's the equation of directrix?
X equals 1.
So,
X equals 1.
good. Right, so the equation starts with the axis the line crosses. Okay, so it crosses the x-axis, that's what starts the equation, and 1/8, so it's the focal length. Good. Right, see, we need to now write x squared equals negative 20y as a set of parametrics. Now we need to introduce the variable t. Right. So we have x squared equals negative 4ay, format here. So we've got a parabola concave down. Okay, the parabola concave down gives us the parametrics, well, with the negative sign there. So we know the x is 2at and the y value is the variable that changes. Okay. Now all we need to do is find out the value for A and put that into the equation. Yep.
I'm just on the t squared isn't that's the orientation of it, isn't it?
Yep, so x squared equals 4ay.
Yeah, but with the parametrics, like y squared.
Because if I set the parameter in the first box and do a similar setup to that one, I will get those two as my parametric equation.
Okay. You've said that it's the orientation of it is with the y, like it's determined by which one's squared, which side's squared. It's just confusing.
Alright, okay. Maybe we need to do that approach there. So when you have your concave up, concave down parabola, the x is what we set the parameter as, and then we have the sideways open parabolas, it'll be the y that we set the parameter as.
What you're thinking is the square value
Yeah. is which
You have to
orientation
just-
it is.
Yeah.
Roll the
I can
square,
now see,
throw the
yeah.
square over the other one.
So it's not, it's the opposite.
It's the opposite.
It's the opposite, okay.
Alright. Thank you, Robin. Alright, so that makes it y is x squared, negative x squared on 4a, which is a negative 2at all squared. Notice the difference now with the negatives used, because this negative is not part of the square. It's just negative came from out the front of the negative of the 4 here. Right, so that's how you derive it if we've forgotten or you need help with the understanding of the orientation and the values of the parametrics. Okay, so the last thing we need to do, so you either need to learn this off by heart or you need to derive it each time. Okay, now the last thing we need to do is we actually need to find the value for A and substitute those in the equation. So what's A?
5.
Pardon?
5.
5, yep, so negative 4ay. Okay, so therefore x is going to be 2 times 5, so 10t, and y is going to be 5t squared. Negative, so 5t squared. Alright, if there's any questions on any of that, you need to speak now because I'm just about to move on to something that's going to involve a lot more algebra, a lot more equations. Okay, so we're comfortable enough with that, knowing what's going on. Alright, so what we're going to do now is we're going to derive a lot of the equations involving chords, tangents and normal to our parabola x squared equals 4ay. Okay, so it can involve a lot of algebra. However, you are both familiar with the concepts that we're about to work through the lesson. It's just going to be a bit messy at some point because there's a lot of things involved. Okay, so 11.1. So chord, tangent, and normals. Okay, so the following equations we're going to derive are all based on our parabola x squared equals 4ay, so our standard concave up parabola with the vertex at the origin. Okay, there is no, reading through the syllabus, there's nothing to suggest that we're going to be looking at this in any other orientation. Okay, so no concave down or opening out to the side. Okay, to do that. However, if there was to be the case where they introduce a different orientation of the parabola, we can still technically do the maths. Okay, but I don't think they will do that. Okay. So what I'm about to derive are the general proof for the properties involving chord, tangents and normals to the parabola x squared equals 4ay. Alright, so page 109. Okay, so there are 7 properties we're going to get through today, hopefully. Hopefully. But I'll take tomorrow's lesson if I need to. Okay, so number 1. We need to consider 2 points, P, 2AP and AP squared, and Q, 2AQ, AQ squared. Right, so we've got P's and Q's represented by their own lowercase parameters. Unless you're told specifically about where P's and Q's are, because they're just representing any 2 points on your parabola, generally I like to have them on the opposite side. So P, 2AP, AP squared. So there's one parameter for the point P. And then on the opposite side, and I'll usually do it on a lower slope, so the gradient's positive. Okay, I've got Q there. 2AQ squared. So just matching what we've done already in terms of parametric equation involving the parameter T. But for the point specifically P and Q, we've got our own lowercase parameters. Okay, and the value of it will change depending on, obviously, the location of them. So we need to now find the gradient of the chord PQ. So we need to find the gradient and the equation of that chord. Okay, so using your mathematics skills, let's derive the equation. Okay, so what's the first thing you need to do? Or in other words, we find the gradient. Alright, so the gradient, you can do it your way if you want, okay, but I'm going to step it to gradient and then point gradient formula. Okay, we'll go for it. Well, I've never learnt that one, I've just always found the gradient substituting the point gradient formula. That does both the gradient and the point gradient formula into one. So y take away y2 over x. Hey? Sorry, y take away y1, x take away x1 is equal to y2 take away y1 over x2 take away x1. But what's this? What's on this side?
It does everything.
Yes.
It's the thing. You just saw.
But what is this?
That's the gradient.
Okay, but if I rearrange that, that'll be m, wouldn't it? And then I'll bring that up top here. Then y take away y1 equals m.
X take away x1. So
Yeah, I like that one.
Okay, so you can do it that way if you want. But like I said, I've always got the habit of doing just finding the gradient and then substituting the point gradient formula. It's just how I've done it. Okay, but if you want to do it the other way, go for it. Right, so I'm going to make P y2 x2s, x2 y2, and Q is going to be x1 y1. So it's going to be AP squared take away AQ squared over 2AP take away 2AQ. Now, of course, we don't know the sign, okay? That'll all depend on the value for P's and Q, okay? Because the focal length is always constant. However, just representing the equation, that's all the info we know. Alright, so I want the gradient in simplest form. So what do I need to do? Factorise. A, P squared take away Q squared over 2A, P take away Q. The A's cancel. Okay. P squared take away 2Q squared and not cancel with P take away Q. That's all I need to do first. Not expand. Other way around. Factorise. Difference 2 squares. Yeah? We've done this a while ago now. So P take away Q. P plus Q over 2 outside of P take away Q. Okay, and now we can cancel. Alright. So the gradient of the chord PQ represented by the parameters P and Q is the sum of those parameter values divided by 2. Okay, in other words, the average of those two parameter values. Okay, so if From that, we now need the equation of the chord PQ. So now we have the gradient, we have one of either of those points, we now need to write down an equation. So y take away y1 is m, x take away x1. Now, it doesn't matter which one you use. You can use your P points here, or you can use your Q's. Alright, you will get the same answer.
I'm just jealous because you have no friends.
Alright, so typically you'll probably use P's in your formulas. So typically your questions are going to be P's and Q's. Alright, so I probably would lean towards using P's, generally speaking, but that's just how I would do it. Okay, it's up to you. So y take away AP squared is equal to P plus Q over 2, x take away 2AP. Now, the notations in your book have got some very interesting way of representing these lines. Okay, so I've told you in the past lines are representing the form y equals mx plus b, or ax plus by plus c equals 0. Okay, but for some reason, when we get to parametric equations, those rules are out the window. Okay, and we've got these formats here. We've got y take away x plus constant equals 0. Okay, don't ask me why, I do not know. Right, so let's try this up. So we need to bring the 2 up this side and multiply. 2y take away 2AP squared is going to be P plus Q outside of x. I'm not going to expand that first term. Take away 2AP P plus Q. Okay, so I've set it up so I can expand. 2y take away 2AP squared is equal to P plus Q outside of x. And I'm going to expand this, okay? Because what will happen, we've got 2AP squared, and we'll be able to simplify it with the term out here. That's why I'm doing that. So take away 2AP squared, take away 2APQ. So we've got the negative 2AP squared on both sides. Okay, so they'll cancel. And then the format that the that your answers like. Okay, so 2y going on the left side of the equals. We need to move this over to the left side. Take away P plus Q, lots of x, plus 2AP Q is equal to 0. And then I'm just going to divide each term by 2. Okay, so divide everything by 2. Get y, take away P plus Q over 2, lots of x, plus APQ is equal to 0. Okay, so the chord PQ on your parabola x squared equals 4ay has the gradient of the average of the parameters, okay, and the equation of the chord is that. Alright? Number 2. Consider when PQ is a focal chord. Okay, so what was the condition for the focal chord? Going back to your locus and parabola work in mathematics. Hey? It does involve a 1. Focal chord goes through the focus. Focal chord goes through the focus.
Pretty hard.
Yep, so hard, eh? Alright, so we now need to consider what happens when we have the chord goes through the focus. Alright, so the focus is at 0, A. Now we're going to substitute that into equation 1. So we've got the chord PQ. Now we have a point that's not represented in parametric form. Okay, so we've just got a constant value 0 and A. For the point, let's substitute x's and y's as 0's and a's respectively into that equation there. So it becomes A, take away P plus Q all over 2, lots of x, which is 0, plus APQ is equal to 0. Yep, tidy it up. A equals APQ, negative APQ. So PQ is going to be negative 1. And this is an extremely important property. Okay, so whenever you talked about, whenever a question refers to as the focal chord, or you see the parameters P times Q equals negative 1, okay, you have a focal chord. Okay, and the importance of this will be highlighted as we work through the rest of the chapter. Okay, but one of the things you're going to walk away with today, PQ equals negative 1. Okay. So PQ is focal chord, then P times Q, PQ is negative 1. Right, questions? Alright, now we want to consider the gradient and the equation of the tangent to the parabola x squared equals 4ay at the point P. So back to the original parabola, let's put a tangent at P. So now we've done the first few lessons in calculus, in mathematics, we can now do the work on parametrics involving calculus. Alright, so consider the gradient and the equation of the tangent. Okay, so we need to now have the gradient and the equation of that line there. Okay, so using your calculus skill, we need to find the gradient and the tangent. So the equation x squared equals 4ay is the equation of the curve. So to be able to calculate the derivative, what did you notice about all the examples in mathematics and that we don't have here at the moment? Yes, this is an x squared equals. So whenever you're calculating the derivative, you need to have it f of x equals, if it's in that notation, or in this case, y equals. So y is going to be x squared on 4a.
One of my questions, I kept trying to flip it around and get y as a b, and instead of doing that, I just put an imaginary y there and I got the right answer.
We don't talk about imaginary numbers until we get to complex numbers.
I tried so hard.
So
I was trying to derive with like fractions and whatnot,
Yeah.
and I couldn't get it. So I just made the y. I just put a y equals, and I got the right answer.
And you flicked it. Is that what you're saying?
I don't understand.
Well, now we're going to see how it works. Alright, so we're going to have some benefit for today. So, now we have an equation y equals some function of x. Right. The derivative. Who thinks they can tell me what the derivative is?
2x over 4.
No, that's not correct.
Um,
What do you think, Nicole?
going to
The first line, Nicole.
the first what?
The first line, not the final answer.
I've got x squared times 4a negative 1.
No.
And then
rather than much closer.
2x
times
over
Say your original answer again.
2x over 4.
No. Yeah, just that answer.
X over.
Alright, if we had y is equal to 2x squared, what is the derivative?
4x.
Yes? So you bring down, multiply by the constant out the front and take 1 off the power. Okay, you're doing exactly the same thing here, except the constant out the front is a fraction.
So
1 over 4a is that constant out the front. Okay, it's almost like saying y equals negative, 1 on 4a times x squared. So what's the derivative? Try again.
1 over 4a. X.
Yeah, keep going.
Yeah.
2x. So what's 1 times 2x?
Why is it squared? How do you get rid of it?
You bring down the power and take 1 off. Decrease by 1.
Isn't it 2?
Okay.
Isn't the power already 2? Oh wait, we're still in y equals okay. So it's 1 over 4a. No, 2. 1 over 2a. At the front of x.
Yes, which simplifies to x on 2a.
I get it now.
Alright, did we both follow that though? Yes? Okay, so that's what you need to know. Right, so we found the equation of the gradient of the tangent at any point x on our curve. Okay, so now I need to know the specific gradient of the tangent at a specific value x, which is, what's the value for x that we're going to use?
0. No, 2ap.
We're finding that, yes? X is 2AP, because we need the gradient tangent at that point x. Okay, your y dash is going to be 2AP over 2A, which simplifies to,
Oh my god.
P.
It's all connected.
so the gradient of the tangent at the point P, using your parametric, is the parameter P. Okay. Y, take away y1, is equal to m, outside of x, take away x1. Now we need the equation, of the tangent. So y, take away a p squared, is equal to p, outside of x, take away 2ap. Right. Expand, tidy up.
I can do that.
And again, they've got this weird thing going on in terms of y's before x's. Right, but it's just how they do it in parametrics.
Y equals px. Wait, it's 2ap.
It's not.
Oh,
It's 2 and 1.
I'll try it.
Y take away
AP.
px plus ap squared is 0. Okay, so that is the equation of the tangent at the point P on the parabola x squared equals 4ay. Okay, just have a look at the rest of that page, 109. See all the formulas there. Okay, now about 2 years ago, when I was teaching Matthew and Cooper, okay, they were preparing for their first HSC assessment task on this. Okay, they prepared for that assessment task by trying to memorise every single formula that's on that page. Okay, and me being a very inexperienced mathematics teacher, because it's the first time I've taken it through and the first time I've taught parametric, okay, I just let them do that. Okay, I'll let them remember it, and they got a very poor result in that section of the exam because they tried to remember too much and just didn't apply the mathematics. Okay, So, now that I have learnt from this experience, what I'm telling you guys is there is no way you're going to remember all those formulas on the page. Correct? Okay, you prove me wrong, but there is no way you're going to remember them all. Right? So, what I want you to do is focus on how the formulas work. Okay, which is why we're going to take a couple of lessons and go through them all. You can understand, because you both should know how to derive gradient. You should both know how to come up with equations of straight lines using the gradient and a point. Okay, and that's how you're going to focus your answers on. Okay, on the mathematics side of things, rather than trying to remember specific formulas. Okay, so the purpose of this is, one, derive all your formulas as such. If you want to learn them, go for it. If not, let's focus on the math. Okay, and two, it does actually brush up quite significantly on our algebra skills, equation skills. Okay, and three, it does cover 2 or 3 chapters worth of work at once as well. So it's almost like having a revision lesson incorporated in this. Okay, so that is why I'm going through the deriving of all the formulas, which will be finished on tomorrow's lesson. Okay. So, that's now equation number 3. Alright, time for 1 or 2 more. So we've just, in that box, the tangent to the parabola h squared equals 4ay at the point P, 2ap and ap squared, has gradient P, which is just done there, and has equation y take away px plus ap squared equals 0. Okay? Number 4. Are there any questions so far? You're both following how to work these things out, because that's what I need you to walk out of today to be able to do. Consider the equation of the tangent to the parabola x squared equals 4ay at the points P and Q. So back to the original diagram. Okay, so there's the tangent at Q. So that's why when you set these up and you not told anything about the point, that's generally best how to locate your 2 points. Okay, because there's tangents involved, it just makes it easier to be able to grasp it together. So, we need to now derive the intersection point of those 2 tangents. Okay, we need to find that point. So, thinking about your mathematics skills, how would I find the intersection point of 2 straight lines?
You substitute them into each other.
So you have 2 equations, the equations are both a straight line, and you solve them simultaneously to get the value for x and y, correct? That's exactly how we're going to do it here. Alright, so we have the equation of the tangent at P, so we need now the equation of the tangent at Q. Hey?
Is it the same thing?
Not quite. What changes?
The squares.
Hey?
The squares flip around, sorry.
The P's to the Q's.
Yes. Okay. So, similarly, instead of going through and deriving it all again, you're understanding the concept of your parametric equation. Similarly, tangent at Q has equation. And you can do this, okay? You can say this in your exam. If you've already derived something in terms of one variable and you need the same concept for your other variable, don't go through and derive it all again. Just say, using this, the equation is, it's going to be y take away qx plus a q squared is equal to 0. And of course the slopes and all that will all be dependent on the values for P and Q. Okay? So, that's now equation 4. We now need to solve these 2 equations simultaneously. So let's just write them both underneath. So y take away px plus ap squared is 0. Y take away qx plus aq squared equals 0. Right, so how are we going to solve this simultaneously? So y equals px take away a p squared, and y equals qx take away a q squared. 4, 5, 6. So we're going to put number 6 or number 5, number 6, doesn't matter. So rewriting it, it's going to be px take away a p squared is going to be qx take away a q squared. So that's what you need now to solve for x. Thinking about what you need to do with your algebra skills. Solve for x.
Get everything on the, get the x on the one side.
Good. So the AP squared and the AQ squared are constants, okay? They're treated like constant numbers, okay? And the PX and QX both have the variable x, okay? So P take away Q, lots of x, it's going to be A. P take away Q, P plus Q. Okay, doing similar setups to what I've already done before in terms of that factorising. I can cancel everything on the denominator because of the minus sign, as long as there is a factor of that up the top. And when I mean factors, I mean these three terms are multiplied, and that entirely is the factor on the bottom. Okay, that's why I can cancel. Okay, I can't just go P, cancel that P, and I can't go Q, cancel with that Q. I can't do that. Okay. So the x value is going to be A outside of P plus Q. So add the two parameters together, multiply by the focal length. Right, so we've got the value for x, let's put it into one of the other two equations. 5, doesn't matter, you'll get the same answer, even though there's p's and q's involved in different equations. Okay, I typically like to work with p's, just because p comes first. So y is p times x, so p plus q, take away a p squared. Right, so the tangent to the parabola x squared equals 4ay at the points P and Q intersect at the points x equals a outside of P plus Q and y equals APQ. So we need to write that as a coordinate. Alright, it's 8:35 now. Do you want to stop there? What do you want to do? What do you want to do the next one? Well, I'm going to go through the next lesson. But I really need to go to the bathroom first.
We'll go.
Alright.